In this video, I'm going to talk about limit of absolute value function. Let's begin with the piecewise definition of an absolute value function. Basically, absolute value for every real number returns is positive part. So absolute value of a real number a is a when it is greater or equal 0, and it's negative a when it is less than 0. For example, absolute value of 5 is 5 because 5 is a number greater than 0, and absolute value of negative 5 is 5 again. Okay, it is like you multiply negative 5 by another negative to have the positive part of negative 5. So for every positive real number a, absolute value of a is a itself, but absolute value of a when a is a negative number is just negative a. We just multiply a by negative 1. Let's solve an example for absolute value of a function. For example, absolute value of x plus 1, we can assume x plus 1 is a. So just substitute x plus 1 in a in the above formula. So absolute value of x plus 1 is x plus 1 when x plus 1 is a number greater than or equal to 0, when it's positive. And it is negative x plus 1 when x plus 1 is a negative number. So you can see we just substitute x plus 1 into the above formula here, which is absolute value of a is a when a is positive, it's negative a when a is a negative. So we just substitute x plus 1 as a into this formula. So you can see we have this formula, but what we have here is just interval is for x plus 1, not x. What we usually want is interval for x. So we can just simplify the interval to have a function, a piecewise function with interval for x. So again, we can say this absolute value of x plus 1 is x plus 1 when x is greater than or equal negative 1. So just rewriting x plus 1 greater than or equal to 0 into x greater than or equal to negative 1. And it's negative x plus 1 when x is less than negative 1. So that's how we can just have a piecewise definition for absolute value of a function, or a function which includes absolute value. And we're going to find this piecewise form to solve limit of absolute value functions or function include absolute value. Let's solve an example. Limit of x plus absolute value of x when x approaches 0. So first we find the piecewise definition of x plus absolute value of x. So here what we need to find is piecewise definition of x plus absolute value of x. So we back to the definition of absolute value of x. So it was absolute value of x is x when x is greater than or equal to 0, and absolute value of x is negative x when x is less than 0. So x plus absolute value of x is x plus x when x is positive but it's greater than or equal to 0, and it is x plus negative x when x is a negative number. So again, we can just simplify the equations. So it is just 2x when x is greater than or equal to 0, and it is 0 when x is a number less than 0. Now we can solve the limit. So you can see the right-sided limit of x plus absolute value of x when x approaches 0 is 0. So the equation x plus absolute value of x when x approaches 0 from right side, that means the value of x is bigger than 0. So what we use is the first equation, which is 2x. So the equation is 2x, limit of 2x is 0. And the left limit is also 0 because the equation for the values of x less than 0 is 0. So limit is again 0, therefore the limit is 0. Okay, let's solve another example. Limit of absolute value of x over x again, we find the piecewise definition, piecewise form of this function. Here we have absolute value of x. So absolute value of x is x when x is greater than 0, it's negative x when it's less than 0. So absolute value of x over x is x over x when x is a positive number, and it's negative x over x when x is a negative number. And if we simplify the function, the equation is 1 for positive values of x, and it's negative 1 for negative values of x. And now if we find the one-sided limits, the right limit is the limit of 1, and the limit is 1, and the left limit is negative 1. You can see the right and left limits, they're not equal, therefore the limit of absolute value x over x does not exist. Okay, let's solve this example. Limit of absolute value of x squared minus 1 by x minus 1. Again, what we need to find the piecewise form of this function, absolute value of x squared minus 1 by x minus 1. So again, using the definition of absolute value of a is going to be x squared minus 1 by x minus 1 when x squared minus 1 is greater than or equal 0. So you can see the simplified form is x plus 1. If you just factorize the numerator, is x plus 1 times x minus 1, so cancel x minus 1, and the equation will be x plus 1. But what we have here is x squared minus 1 is greater than or equal to 0. So it's a little bit weird interval for x. So again, for negative values, again, we have negative x squared minus 1 by x minus 1, which simplified form is negative x plus 1, when x squared minus 1 is negative. So again, what we need interval for x. We need equation of function for intervals of x, not interval for x squared minus 1. We need to find where x squared minus 1 is positive or where x squared minus 1 is negative. To solve this one, we need to find the sign of this function x squared minus 1. And the best way, or maybe the easiest way, is just study the graph of this function. X squared minus 1 is a quadratic function. Zeros are negative 1 and 1. So you can see this function is positive. This function is greater than or equal to 0 when x is less than or equal negative 1 or greater than or equal 1. So this is where x squared minus 1 is greater than or equal to 0. So now we can say this function x squared, absolute value of x squared minus 1 by x minus 1, its equation is x plus 1, where x is greater than or equal to 1 or x is less than or equal to negative 1. What about the second equation? X squared minus 1 is negative between negative 1 and 1. So now we can say the equation is negative x plus 1 when x is between negative 1 and 1. Now we can use these intervals of x and these equations to find the limit, absolute value of x squared minus 1 by x minus 1. What is the right limit? The right limit is limit of x plus 1, because x approaches to 1 from right side with the values greater than 1, and we can see the equation when x is greater than 1 is x plus 1. So that's actually the limit of x plus 1 at 1, so the limit is 2. What about the left limit when x is less than 1? You can see when x is less than 1, the equation is negative x plus 1, and the limit is negative 2. Again, now here for this example, left and right limits, they're not equal, therefore the limit does not exist. Thank you for watching the video.